Okay, all right. So here we go, ladies and gentlemen. We are going to jump on to OneNote, and I'm gonna look at that. I was planning out our schedule for the rest of the year this morning. Um, we're gonna we're gonna talk today about solving equations, but we're gonna do it where there's gonna be a coefficient on the inside, and so it like if there was a period change, essentially, if there's a period change going on with like a graph. And so I'm going to kind of give you a visual of it. I'll use Desmos to do that. But then I'll also just be doing the algebra side of things. And it's not too bad. You just got to do a few extra steps to find all the answers. But if you've been keeping up, I think you'll find this to be pretty easy. But I want to start off because I know I don't get to hear from everybody. If you want to ask a question about either of these, do you guys have questions about how you would go about solving problems like these two? Anybody? Just throw it out there. I can't see your face or anything. Or such, just unmute your mic and let me know. No? Going once?
First one, I'd factor it.
Yes. First one, we would definitely factor it, right? So 3 sine of x, right? And then I think -1 would be the right thing. And then sine of x minus 2, and that would equal 0. And then this we'd set it equal to 0 each one. So it'd be sine of x equals 1/3. And then sine of x equals 2. Okay, on the count of 3, we'll try this again. I don't know if it worked out well or not last time. But which one would not give you any answers? Yeah, ready? Everybody, ready? On the count of 3. 1, 2, 3.
Sine of x equals 2.
Yes, I know that's not going to translate well to the video when we share it with everybody, but sine of x equals 2. This one does not produce any answers because sine can't be greater than 1. But then for the second one, we would do the inverse sine. You have to use a calculator, right? Inverse sine of 1/3, and it's going to give us an answer in quadrant 1. And then we're going to have to go find the answer in quadrant 2. And so how is everybody doing with that? Having to find the extra answer, the one the calculator does not provide. Is everybody doing okay with that? You got any questions about it? Might as well throw it out now while we're together.
So for this one, would you subtract 2 pi to get the other answer?
No, I don't think so. So I'm getting, in radians, I'm getting that x equals 0.34 roughly, 0.34 radians, right? So here you go. Here's the picture. In quadrant 1, this would be 0.34 radians. We're looking for an angle in quadrant 2 that would have the same reference angle. This needs to be 0.34. And so in order to do that, we would start at 0 and go to here. That's the angle we're looking for, the one in blue. And so the way I would do it is I would do pi minus 0.34. So just pi minus the answer that I had just gotten. And then it would equal, oops, I got x equals 2.80 radians.
All right, thank you.
Yep. All right. I know I have work to do today on the quiz that people are taking. Give me some feedback real quick. Do I need to check to see if like some of the decimals are off? It's just a curious question. Like, I know some of you are getting like 9.8 out of 10. Like, do I need to go?
Yes, because one of them I got like everything right except for like 0.2, and I'm pretty sure it's right.
Okay. All right. I'll go through and I'll look at them today. But I was seeing that and I was like, I probably need to go check answers and see if I just need to give you the credit for it. So I'll double check through those today. And if I don't get to yours, but you have questions, send me an email. In the second one, I would divide by cosine. For those who are curious and you see something like that and you just immediately want to do menu 3-1, don't do that, right? So I'd say 3 tangent of x equals 7, divide by 3. Tangent of x equals 7/3. And remember, tangent can equal something bigger than 1. So we can just go about it. X equals the inverse tangent of 7/3. and then I'd have to use my calculator. And this is the one where you would add like pi, right? So inverse tangent of 7/3. I don't know if everybody else is getting the same thing, but I got 1.1. Oh, let's admit Aiden. Aiden, how are you feeling? Yay. Hopefully Aiden's doing good. 1.166 radians. Okay. All right. And then I would add pi to find my next one because this one's in quadrant 2. No, false. Where is it? Quadrant 1? Do you agree with this? 1.166? Nobody's talking to me. I love you guys. And then I would add pi to figure out where the other one is. Okay. X equals 4.307. That's what I got. Okay. Questions before we move on solving? No? No? All right. If you hear my kids, it's because it's snack time and arts and crafts time at my house. So here we go. All right. Let's get started. Okay. So talk to me. Everybody should know how to solve this one, right? 2 cosine of theta minus 1, right? We would get cosine of theta equals 1/2. And how many answers would you get from cosine of theta equaling 1/2? How many answers?
2.
2. We would get 2 answers. Okay. Obviously this looks weird. You got this 3 theta on the inside, but solving it would be very similar. I'm not going to say the same. You'd get that alone. So you'd have cosine of 3 theta, and that equals 1/2. Okay. And while we may think there's 2 answers, there's actually not going to be 2 answers. So here's what we're going to do. I'm going to share with you something different real quick. Here we go. Gonna get to our good old favorite Desmos. So here's your cosine of 3 theta equals y. Oh my word, why is this not graphing? Why? Oh, I have to use x, silly goose. Okay, so there you go, right? So here's cosine of 3x, y equals cosine of 3x. And like 2 pi would be, would you agree 2 pi would be roughly like somewhere right here? Everyone's good with that? Somewhere over here. So you get 3 cosine curves in, 1, 2, 3. And if you were saying, okay, well now where is it 1/2? Y equals 1/2 if we're solving. If you take a look, y is 1/2 here, 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 and there. Okay. And so instead of getting 2 answers, we end up getting 6 answers. And the reason being, right, if I go back to OneNote, okay, what's the matter? Tell me. The reason we're going to get 6 answers. Oh, did somebody have a question? Sorry. Okay. The reason we're going to get 6 answers is because remember, what does this 3 theta mean? That means now from normally where you would go from 0 to 2 pi, instead of getting 1, right, because 1 theta, instead of getting 1 cosine curve from 0 to 2 pi, you're actually going to get 3 cosine curves. So if cosine normally equals 1/2 2 times in one period, it's now going to equal 1/2 6 times over those 3 periods that will fit from 0 to 2 pi. So the question for us today is how algebraically will we find all 6 answers, right? Like what's going to be the best way to do it? And so the best way to do it is to start by first talking about how to find all solutions. At least that's the way I teach it, is to start with finding all solutions, and then we'll go back to how do you find them from 0 to 2 pi, okay? Because it should lend itself pretty nicely to that. All right, so how would you find all solutions for the one that we just graphed, right? So I would get the trig function alone. Right, that's the first thing I'm doing is getting the trig part alone. So I'll say cosine of 3 theta equals 1/2. And then you're going to need to solve it like normal. So using our skills, on the count of 3, we're going to say the 2 angles where cosine is 1/2. Get ready. On the count of 3, we're going to say the 2 angles where cosine is 1/2. Ready, ready, ready. 1, 2, 3.
Pi
Pi thirds and 5 pi thirds.
Pi thirds and 5 pi thirds. All right. But instead, right, since we're finding all solutions, I'm going to say, and it's not going to be theta equals pi thirds, but it's going to be 3 theta equals pi thirds. And then normally we would add 2 pi n to find the coterminal angle, right? And then I'm going to say 3 theta equals 5 pi thirds plus 2 pi n. And so since I'm solving like normal, I'm now going to create equations, right? Create equations for each, right, angle. All right, so you've got 3 theta equals pi thirds plus 2 pi n, and 3 theta equals 5 pi thirds plus 2 pi n. All right, and so then from there, we're going to solve for theta. Okay, so since there's a bunch of stuff going on in here solving for theta, I'm going to multiply both sides by 1/3. If that's all right with everybody. Instead of dividing by 3, that just doesn't sound exciting to me. I'm going to multiply by the reciprocal. So that would be what? Theta equals pi 9th plus 2 pi thirds. And then theta equals 5 pi over 9 plus 2 pi thirds n. And so this would be the statements for all the solutions, okay? Now that might not make much sense. So let's kind of add in, not that we would need to with these instructions, but let's just add in the wrinkle of what would you do now if it had to go from 0 to 2 pi? Like if you were finding all the answers that I had previously shown on the Desmos graph, right? Well, first off, here's your first answer. Pi over 9 is your first answer. And then what our statements are saying is that all you have to do is keep adding 2 pi thirds to find more answers. So if I get it in common denominators, do you guys agree that would be what, 6 over 9? Yes? Agreed? No? Silence? Okay, you can tell me yes or no. 6 over 9?
Yes.
Thank you, Emmy. Oh, so glad you're here. All right, so then 7 pi over 9. And then let's see what else. 6 pi over 9 again. What would that be? 13 pi over 9. And then another one would be 19 pi over 9. And then another one would be like 25 pi over 9. But here's the thing. If we're going from 0 to 2 pi, like when it says solve for all things from 0 to 2 pi, right? If you're going from 0 to 2 pi, your angles can't be bigger than 2 pi. Well, what's 2 times 9? 2 times 9 is 18. So you actually can't go with these, right? And so I would have stopped with 13 pi over 9. And that would have found all my answers for the first statement. Then for my second statement, I would have said 5 pi over 9 is the first answer. And then I'm adding 6 over 9, so I'd get 11 over 9. And then I'd add 6 over 9 again, and I would get 17 over 9. It's kind of hard to read. 17 over 9. And that would be where I'd stop, because if I keep adding, it would be bigger than 18 over 9, and I can't be bigger than 2 pi. So if we're breaking down the instructions, right, here's all solutions. If it was all solutions, which our instructions were, I would have stopped right here. So if you're writing yourself some notes, these are the all solutions answers, right? I would have stopped here. That's much easier, right? Like that's the one you pray for on the test because you're done at that point. But if it's 0 to 2 pi, if it says find all solutions from 0 to 2 pi, then you actually have to like physically go find them. And that would be And I would use the statements that I've created to find them. And this is how I got my 6 answers, right? I got these 3 from the first and these 3 from the second. And if I were to share with you my graph one more time. Oh no, we lost it. 1, 2, 3, 4, 5, 6. So if you're taking a look at pi over 9, let's get rid of that. Let's get rid of this. Okay, nope. Is that what I wanted to get rid of? I don't want to get rid of this one. So if we were adding 6 over 9 each time, right? If you're taking a look, it's just the, how do I do this? How do I do this? Can you even, I don't know. If you take a look at the black dots that I've labeled, I don't have a way of highlighting them, but if you take a look at the black dots that are labeled, those are the same exact dot, right? Or the same exact spot. They're on the down slope of the curve. They're essentially coterminal angles, right? And they're kind of in the same place. And so that's what you're finding, is you're finding all these angles that would produce the same trig value, but now the period's been shortened. So you're just gonna get more answers, okay? All right, tell me your thoughts on that. Questions that arise, things that come up, things you wanna say. That made 100% sense? Yes?
Yes.
Yes.
Wow, I'm the greatest.
Indeed.
Greatest teacher to ever live. All right, so anyway, here we go. Let's try it again. So if I'm solving this, right, I've got tangent of 1/2 theta equals, let's see, subtract 2, divide by 2, -1. So on the count of 3, just answer me this. How many places does tangent equal -1? Right, on the count of 3, how many places does tangent equal -1 on the count of 3? 1, 2, 3.
1, 2, 2.
2.
2. The answer's 2. The answer's 2. There's 2 places. But here's how you know how many answers you're going to be finding if it's from 0 to 2 pi. If there's that 1/2 theta there, so if you normally would get 2 answers, but now it says 1/2 theta, then we're actually only going to get 1 answer that would fit in the interval of 0 to 2 pi. Is that making sense? How to kind of figure out how many answers you're going to end up with if you had to go find them? Yes? No? Okay, thanks, Nate. Nate's got it.
Yes.
All right, cool. So, but this one I think was all solutions, right? So let's just find all solutions. So here we go. Tangent of 1/2 theta equals -1. I would say 1/2 theta equals, right? And -1 means, I'll do the first one for you. You should be saying 3 pi over 4 in your heart. In your heart, you should be confessing loudly 3 pi over 4 plus, and I'm not going to do 2 pi n. I'm going to just do pi n. Because what's the next angle that would get you -1? It would be 7 pi over 4. And that's pi away, right? So in tangent, you really only have to write the one statement, and that will encompass all of those. So hopefully that makes sense, what you would have to find. And then I'm going to multiply everything by 2 so that theta is 1. So then theta equals, I don't know, 3 pi over 2 plus 2 pi n?
Yep.
Great. John, he is late to class. Welcome, John. I don't know if you can hear us, but did you guys all hear that beautiful noise? Did everybody hear that, or just me?
Just you.
Darn, you guys really missed out. Okay, anyway, so then that's all my answers, all right? If this is all solutions. If you had to find, oh no, we have 10 minutes. All solutions, right? And we'll get it done. But if you had to go find from 0 to 2 pi, then this would be your first answer, and you would just keep adding. But since you're adding 2 pi every time, right? That's what this means. You're adding 2 pi every time. You wouldn't add anything. That's why there's only one answer. All right. So let's do a couple where it's.
Wait, I have a question.
Oh, go ahead.
Why is it 3 pi over 4 and not 7 pi over 4?
Because I just found the first one where it was -1. Like in quadrant 2, I thought of quadrant 2. I didn't think of quadrant 4. Like quadrant 2 is 3 pi over 4, right? And then pi away, 7 pi over 4, it's also -1. So that's why I just did 3 pi over 4 plus pi in. I didn't need to write two statements.
You didn't have to do like the inverse or anything like that?
Nope.
All right, cool. Thanks.
Okay. Not if they're nice ratios, which they should all be nice ratios on tonight's homework, which I'll put up after this. All right. Okay. So here we go. Find all solutions. So we're going to get sine of 2 theta alone, which is going to equal -1/2. Okay. So everyone's going to tell me where sine is -1/2 on the count of 3. 1, 2, 3.
7 pi 6
7
and
pi 6 and 11 pi.
Thank you. 7 pi over 6, right? Plus, and then we're going to say 2 pi n. And then we're going to do 2 theta equals 11 pi over 6 plus 2 pi n. Okay. And then we're just going to solve for theta. And after we solve for theta, we're going to have to actually find answers now because it says find all of them from 0 to 2 pi. So I'll multiply by 1/2, multiply by 1/2. I get theta. Whoa, 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 whoa. Settle down one note. Theta equals what? 7 over 12, 7 pi over 12 plus pi n. And theta equals 11 pi over 12 plus pi n. Common error is people don't distribute correctly, right? And that causes everybody to have messed up answers. So make sure you distribute correctly, but if you distribute correctly, then, you know, life will be good. So then our first answer is going to be theta equals, right, 7 pi over 12. That's my first one. And to find the next one, I'm going to add pi. So 12 over 12, 19 pi over 12. Okay. And then the next one, once again, 11 pi over 12 is my first answer. And then I'll add 12 over 12 again, which would be 23 pi over 12. Does that sound okay to everybody? Yes?
Yep.
Perfect. Thanks, Emma.
Yep.
Okay. So there's your 4 answers. So kind of an easy way to check yourself would be, right, this equation, if it was just theta, sine of 2 theta equals -1/2. If it was just theta, you would have 2 answers. But if you take the normal number of answers and multiply it by the coefficient on the inside, that'll tell you how many answers you should end up with from 0 to 2 pi, right? So it should be a nice, easy way to check yourself. So 2 times 2 is 4. I got 4 answers. I feel good. Okay. All right, let's try to solve this one as the clock ticks on us. 6 minutes remaining. Oh my word. -2. Sometimes I got to do it out. -2 secant of 1/2 theta equals 4. Divide by -2. I get secant of 1/2 theta equals -2. Sometimes I'm not very good at thinking in terms of this, so I'm going to say cosine of 1/2 theta equals the reciprocal, so -1/2. Does that sound okay? -1/2. And now we got to figure out where cosine's -1/2. Been a minute, guys. It's been a minute. I've been keeping up on my trig tables. Here I go. I got it. Quadrant 2 and 3. 1/2 theta. Do you agree? 2 pi thirds? Yay or nay? I love the excitement.
Yeah.
Yay. Plus 2 pi n. And then 1/2 theta. I think what, 4 pi thirds?
Yep.
Yes. Plus 2 pi n. Okay. All right. So here we go. Now we're going to get theta alone and find all our answers. So I'll multiply by 2. It's going to be what? Theta equals 4 pi thirds plus 4 pi n. 2. And then theta equals 8 pi thirds plus 4 pi n. Okay. Now, once again, remember, you got to find all your answers from 0 to 2 pi, right? So if I got to use only 0 to 2 pi, I can't even use 8 pi thirds, because 8 thirds is like 2 and 2/3. So it doesn't even work. So nothing's going to come from this. Then my first answer is 4 pi thirds. Theta equals 4 pi thirds. But I wouldn't have another one, because if I add 4 pi to it, then it's clearly greater than 2 pi. So then this is my only answer. How's everybody feeling about this? That's kind of the main
Good.
stuff. Questions you want to ask? We got about 3 minutes left.
That one, if there were to be another one, like if it was, like would you be adding 4 pi in, or just?
Yeah, you would just add 4 pi, like if you
Okay.
needed to find more. So then you'd have to get a common denominator and then go through it that way. So like
Thank you.
12 over 3.
Yeah, okay, thank you.
Mm-hmm. Okay. I just wanted to do one where I just want to remind everybody what happens when pi with graphing, you know, who knows if there's a final someday? Probably not. I don't know. What do you guys think? What's the chances we're going to have a final? Probably 0. But I don't want to get your hopes up. So anyway, here we go. So solve for all solutions, right? Remember when you were graphing and there was a pi on the inside? Do you remember what happened, right? When you found the period? Anybody? Do you remember? Like if you had to do 2 pi divided by pi over 2, do you remember what happens? No? Yes? No?
The period is just 2.
No. Well,
Oh.
in this case, it would be 4, right?
Pi.
Oh, yeah.
The pi's cancel out, I think is what Paige said. So don't freak out if that happens, okay? So just check this out, right? So subtract 1, get -1 equals sine of pi over 2x. And so then we're sine -1.
3 pi over 2.
Sweet. So I'd say 3 pi over 2 plus 2 pi n, because I got to find all my solutions, right? All solutions. And then I'm going to multiply by the reciprocal, so 2 over pi. And the beautiful thing, like Paige said, is that the pi's are just going to all cancel out. So this will leave you with x. That equals 3, right? And then plus 4n. Does that seem okay? Yes?
Yep.
And if you had to find all the answers from 0 to 2 pi, the answer would just be 3 radians. Do you agree with this? Just 3? Because if you add 4 radians to 3 radians, that would be 7 radians, which is more than 2 pi. Does that bother you guys? No? Hopefully not. There you go. So that's the answer. Okay. But that's what we're doing today. We're solving equations that look weird like that. Everybody good?
Yes.
Yep.
Yeah,
Okay.
Yes.
All right. Well, that's gonna be it, because they're gonna make me pay for money or pay money to keep it going. So I wish you all the best. If you have lots of questions, send them my way. I will gladly answer them. Okay. You guys be well. I'll talk to you later.
Peace.
See ya. See ya.
Bye.
Bye.